All right, so we're going to move on, and I want to talk now about a different kind of weighted average. These weighted averages are going to be much simpler. And they come up in what's called numerical integration. There are many, many methods of integrating numerically, and they're important because many, many integrals don't have formulas, and so you have to compute them with a calculator or a machine. So these are so now the first type that we've already done are Riemann sums. They turn out to be incredibly inefficient. They're lousy. The next rule that I'm going to describe is a little improvement. It's called the trapezoidal rule. And this one is much more reasonable than the Riemann sum. Unfortunately, it's actually also pretty lousy. There's another rule which is just a slightly trickier rule, and it's actually amazing that it exists. And it's called Simpson's rule. And this one is actually pretty good. But it's clever. So let's get started with these. And the way I'll get started is by reminding you what the Riemann sum is. So this is a good review because you need to know all three of these. And you're going to want to see them all laid out in parallel. Okay? So here's the setup. Okay, so here we go. We have our graph, we have our function. It starts out at A, it ends up at B, maybe goes on, but we're only paying attention to this interval. This is the function y is equal to f of x. And we split it up when we do Riemann sums. So this is one. This is Riemann sums. We start out with A, which is a point we call x0, and then we go a certain distance. We go all the way over to B, and we subdivide this thing with these delta x's, which are the step sizes. All right? So we have these little steps of size delta x. Corresponding to these x values, we have y values. y0 is f of x0. That's the point above A. Then y1 is f of x1. That's the point above x1. And so forth, all the way up to yn, which is f of xn.